Modern air defense systems are designed to detect, track, and destroy incoming threats within seconds, yet even the most advanced networks have limits. One of the quieter but most effective ways militaries test and exploit those limits is through the use of decoy aircraft, and Israel has become one of the most experienced users of this approach in real operational environments. This is not about secret superweapons or dramatic technological breakthroughs. It is about methodical planning, careful intelligence work, and the practical realities of operating in airspace protected by layered radar, surface-to-air missiles, and command and control networks. Israel's use of decoy aircraft reflects decades of adaptation to hostile air defense environments, particularly in the Middle East, where airspace is dense, contested, and politically sensitive. To understand why decoys matter, it is important to understand the problem Israel faces. Air defense systems today are not single radars or missile batteries working in isolation. They are integrated networks combining early warning radars, tracking radars, command centers, and multiple types of interceptors. These systems are designed to create a picture of the airspace and respond automatically or semi-automatically to perceived threats. Penetrating such a system without unacceptable risk requires more than speed or stealth alone. Israel's air operations are primarily conducted by the Israeli Air Force, which has long emphasized intelligence-driven planning and technological integration. Over the years, Israeli planners recognized that forcing an enemy air defense system to reveal itself can be just as valuable as destroying it outright. Decoy aircraft are one of the tools used to achieve that goal. A decoy aircraft in this context is not necessarily a full-sized airplane with a pilot on board. More often, it is an unmanned aerial vehicle or missile-like platform designed to mimic the radar, infrared, or flight characteristics of a real aircraft. When launched toward defended airspace, these decoys are intended to trigger radar tracking, missile launches, and communications between air defense units. Each of these responses generates data. That data is crucial. When a radar activates, its frequency, location, and operating mode can be detected. When a missile is launched, its guidance method and engagement envelope can be analyzed. When command centers communicate, their procedures and response times can be inferred. In essence, decoys turn an air defense network into a source of intelligence. Israel's experience with this approach dates back several decades. In earlier conflicts, Israeli aircraft faced Soviet-designed air defense systems operated by neighboring states. These systems were effective and, in some cases, outperformed expectations. Direct attacks, without prior preparation, resulted in aircraft losses and operational setbacks. Those experiences shaped a doctrine focused on suppression and exploitation rather than brute force. Decoy aircraft became part of that doctrine. By sending decoys ahead of manned aircraft, Israel could provoke air defense reactions without risking pilots. Once those defenses were active, they could be targeted by electronic warfare, anti-radiation missiles, or follow-on strikes. This sequence reduced risk and increased the likelihood of mission success. The technology behind decoys has evolved significantly. Early decoys were relatively simple, often limited in endurance and fidelity. Modern systems are more sophisticated. They can fly complex routes, change altitude, and present radar signatures that closely resemble real combat aircraft. Some are designed to appear as high-value targets, drawing attention away from actual strike packages. Israeli defense companies, including Rafael Advanced Defense Systems and others in the domestic industry, have played a role in developing these capabilities. Their focus has been on reliability and integration rather than novelty. A decoy does not need to be invisible or autonomous in a futuristic sense. It needs to be convincing enough to force an air defense operator to respond. Operationally, the use of decoys is tightly controlled. They are launched as part of a broader plan that includes intelligence collection, electronic warfare, and kinetic strike options. Decoys alone do not penetrate air defenses. They create conditions that allow other assets to do so. This distinction is important because it highlights that decoys are enablers, not standalone solutions. From a geopolitical perspective, Israel's reliance on such techniques reflects its strategic environment. The country operates within short distances of potential adversaries, leaving little room for error. Missions are often conducted under intense international scrutiny, where civilian casualties or unintended escalation carry significant consequences. Reducing risk to pilots and limiting collateral damage are not just military concerns but political necessities. Decoy aircraft also serve a deterrent function. Adversaries know that activating their air defenses may expose them to countermeasures. This uncertainty can complicate defensive planning and reduce confidence in the effectiveness of expensive systems. Over time, this dynamic can influence procurement decisions and operational behavior on both sides. It is also important to address the limits of decoy use. Air defense systems are not static. Operators learn, adapt, and update their procedures. Repeated use of the same decoy profiles can lead to diminishing returns. Israel's approach has therefore emphasized variation and intelligence refreshment. Each operation is treated as a unique problem, even if the underlying tools are similar. Modern air defenses increasingly rely on multi-sensor fusion, combining radar with infrared and visual tracking. This makes deception more challenging. Decoys must now account for multiple detection methods, which increases complexity and cost. Even so, the fundamental principle remains valid. Forcing the defender to react creates opportunities for the attacker. Ethically and legally, the use of decoys occupies a relatively uncontroversial space compared to other military technologies. Decoys are designed to avoid direct harm. Their purpose is to mislead systems, not people. That does not remove all ethical considerations, but it does make them a comparatively restrained tool within the spectrum of military options. Recent conflicts around the world have shown renewed interest in decoy tactics. As air defense systems proliferate and become more capable, attackers seek cost-effective ways to overwhelm or confuse them. Israel's long experience in this field offers lessons that are being studied by other militaries, even if specific operational details remain classified. From a strategic analysis standpoint, decoy aircraft illustrate how modern warfare often favors information advantage over raw firepower. The goal is not necessarily to destroy every air defense unit, but to understand how the system works well enough to bypass or neutralize it when necessary. This approach aligns with broader trends in military thinking, where data and decision-making speed are critical. It is also worth noting that decoys are not a silver bullet. They work best when integrated into a comprehensive campaign. Without accurate intelligence, skilled operators, and effective follow-on capabilities, decoys alone achieve little. Israel's success in this area is tied to its ability to combine these elements coherently. As technology continues to evolve, so will the cat-and-mouse game between attackers and defenders. Artificial intelligence, improved sensors, and network resilience will shape future air defense systems. At the same time, decoys may become more adaptive, capable of responding to defensive measures in real time. These developments will raise new operational and ethical questions. For now, Israel's use of decoy aircraft remains a practical example of how states adapt to constrained environments. It reflects a preference for preparation over improvisation and for calculated risk over spectacle. In a region where miscalculation can have far-reaching consequences, such an approach carries significant weight. Understanding these methods helps demystify modern air operations. It shows that successful penetration of air defenses is rarely about a single dramatic breakthrough. More often, it is the result of patient analysis, incremental advantage, and disciplined execution. Decoy aircraft are one piece of that larger picture. Air defense systems are built on the promise of control. They exist to give a state confidence that its skies are protected, that hostile aircraft will be detected early, tracked accurately, and neutralized before they can strike. Yet history shows that even the most sophisticated air defense networks can be stressed, confused, and ultimately penetrated. One of the most practical methods used to test and exploit these limits is the use of decoy aircraft, and Israel's experience with this method offers a clear window into how modern air operations actually work. To understand how Israel uses decoy aircraft, we first need to understand the operational environment in which Israeli air planners operate. Israel is surrounded by regions where air defense systems are not theoretical assets but real, deployed, and often layered. These systems include long-range early warning radars, medium and short-range surface-to-air missiles, mobile launchers, and centralized command and control nodes. In such an environment, simply sending manned aircraft into defended airspace without preparation would be costly and strategically irresponsible. This is where the logic of decoys begins. The core idea is not deception for its own sake but information extraction. Air defense systems only reveal their full capabilities when they are active. when radars switch on, when tracking modes change, when missiles are launched, and when operators communicate with higher command, they leave behind signals. These signals can be detected, recorded, and analyzed. Decoy aircraft are designed to provoke exactly these responses. Israel's air operations are led by the Israeli Air Force, an institution that has historically placed intelligence and preparation at the center of its doctrine. From the Israeli perspective, the most dangerous air defense system is not necessarily the most powerful one, but the least understood one. Decoys help reduce that uncertainty. A decoy aircraft can take several forms. In many cases, it is an unmanned aerial vehicle designed to resemble a manned fighter or strike aircraft on radar. Its size, speed, altitude profile, and radar cross-section are carefully calibrated. The goal is not to perfectly replicate a specific aircraft, but to appear credible enough that air defense operators treat it as a real threat. Once that happens, the system reacts, and that reaction is what Israel is seeking to observe. When a decoy enters defended airspace, the first response usually comes from early warning radar. These radars are designed to detect objects at long range and pass that information to command centers. By monitoring these radar emissions, Israeli sensors can determine their location, frequency, and coverage patterns. This alone provides valuable insight into the structure of the air defense network. As the decoy continues its approach, tracking radars may be activated. These radars offer more precise targeting data and are often tied directly to missile batteries. Each tracking radar has specific characteristics, and identifying them allows planners to understand which missile systems are active and how they are deployed. This process transforms an abstract threat into a mapped, analyzable system. If the decoy is convincing enough, the defender may launch a missile. From Israel's perspective, this is a critical moment. A missile launch reveals not only the location of the launcher but also the type of missile, its guidance method, and its engagement envelope. Sensors can track the missile's flight profile, speed, and maneuverability. This information can later be used to design countermeasures or plan safe flight paths for manned aircraft. Importantly, this entire process can occur without risking a pilot's life. In a region where air losses can have significant political and psychological consequences, this matters deeply. Decoys allow Israel to probe defenses repeatedly and methodically, refining its understanding over time. Decoy aircraft are rarely used in isolation. They are typically part of a broader operation that includes electronic warfare assets. While the decoy triggers radar and missile activity, electronic warfare systems may attempt to jam, deceive, or interfere with those same defenses. This combination helps Israeli planners assess how resilient an air defense network is under stress. Does it degrade quickly? Does it adapt? Does it rely on centralized control or operate autonomously? Another important function of decoys is distraction. By presenting multiple apparent threats from different directions or at different altitudes, decoys can stretch an air defense system's capacity. Operators must make decisions under time pressure, often with incomplete information. This increases the chance of errors, such as misallocating interceptors or revealing additional radar systems. Israeli defense companies have played a role in refining these capabilities. Firms such as Rafael Advanced Defense Systems have developed technologies that support both decoys and the systems that work alongside them. The emphasis has consistently been on reliability and realism. A decoy that fails to trigger a response is operationally useless. One that behaves unrealistically may even alert defenders that they are being tested. Israel's use of decoys is also shaped by legal and ethical considerations. International humanitarian law places obligations on militaries to distinguish between military and civilian objects and to minimize harm to civilians. Decoys by their nature are non-lethal. They are designed to be intercepted or to self-destruct without causing damage on the ground. This makes them a comparatively restrained tool in the broader context of air operations. From a geopolitical standpoint, the use of decoys reflects Israel's need to balance military effectiveness with escalation management. Direct attacks on air defense systems can be interpreted as major acts of aggression, potentially triggering wider conflict. Decoy operations, especially when conducted outside of active combat, can gather intelligence without crossing certain thresholds. This ambiguity can be strategically useful. It is also important to recognize that air defense operators are not passive. They learn and adapt. Repeat. Exposure to similar decoy tactics can reduce effectiveness over time. Israel addresses this by varying decoy profiles, flight paths, and timing. Intelligence collected from one operation informs the design of the next. This continuous adaptation is central to the method's success. Modern air defense systems increasingly use multiple sensors, including infrared and optical tracking. This raises the bar for decoy design. A decoy that looks convincing on radar but emits no heat may be identified as false. As a result, newer decoys attempt to replicate multiple signatures, making them more complex and costly. Even so, they remain cheaper and less risky than losing a manned aircraft. Recent conflicts in other parts of the world have highlighted the renewed relevance of decoys. As surface-to-air missile systems become more widespread and more capable, attackers seek ways to reduce their effectiveness without resorting to overwhelming force. Israel's experience shows that patient, intelligence-driven approaches can yield results over time. At a strategic level, decoy aircraft underscore a broader shift in warfare. Success is increasingly defined by information advantage rather than sheer destruction. Understanding how an adversary's systems work, where they are vulnerable, and how operators respond under pressure can be more decisive than the number of weapons employed. This approach also reflects Israel's broader security culture, which emphasizes preparation and learning. Operations are analyzed in detail, successes and failures alike. Decoy missions generate data that feeds into training, doctrine, and future planning. Over decades, this creates a feedback loop that steadily improves effectiveness. There are limits, of course. Decoys cannot replace all other methods of suppressing air defenses. In high-intensity conflict, kinetic strikes may still be necessary, but decoys can reduce the scale and risk of such actions. They help ensure that when force is used, it is used with a clearer understanding of the environment. As technology evolves, the contest between decoys and air defenses will continue. Advances in artificial intelligence, sensor fusion, and network resilience will shape future systems on both sides. Israel, like other technologically advanced militaries, is likely to continue investing in tools that preserve flexibility and reduce risk. Ultimately, Israel's use of decoy aircraft is not about trickery in a simplistic sense. It is about disciplined analysis, controlled provocation, and learning through observation. It shows how modern air operations rely as much on restraint and planning as on speed and firepower. In a region where mistakes can escalate quickly, this approach offers a measure of control in an inherently uncertain domain. Air defense networks are designed not only to stop aircraft, but to manage information under pressure. They must decide what is real, what is a distraction, and what poses the greatest danger, often in a matter of seconds. One of the most effective ways Israel has learned to penetrate such systems is not by overpowering them directly, but by shaping how defenders see and interpret the airspace. This brings us to another critical element of Israel's approach, using decoy aircraft to overload, distract, and fragment air defense decision-making. To understand this, it is important to look beyond technology and focus on human and organizational limits. Air defense systems may be automated, but they are still operated by people. Radar screens are monitored by crews who must prioritize contacts, follow procedures, and communicate with higher command. Even advanced systems have finite capacity. They can track only a certain number of targets simultaneously, guide only a limited number of interceptors, and process only so much information at once. Israel's use of decoys is designed to push these limits. Israel's air operations are conducted by the Israeli Air Force, which has long understood that confusion and saturation can be as effective as physical destruction. Instead of presenting a single clear target, Israeli planners may introduce multiple decoy aircraft into defended airspace, sometimes from different directions and at different altitudes. Each decoy appears as a potential threat that must be evaluated. From the defender's perspective, this creates a problem of prioritization. Which target is the most dangerous? Which one should be engaged first? If multiple decoys resemble high-value aircraft, such as strike fighters or command and control platforms, air defense operators may feel compelled to respond aggressively. This can lead to missile launches against targets that pose no real threat, consuming interceptors that cannot be easily replaced. This aspect of decoy use is especially relevant when air defense systems rely on expensive missiles. Interceptors are costly and limited in number. Every missile fired at a decoy is one less missile available for a real aircraft later in the engagement. Over time, this can degrade the defender's confidence and effectiveness, even if no physical damage has yet occurred. Another effect of saturation is the fragmentation of the air defense picture. When multiple decoys are detected simultaneously, the air defense network must divide its attention. Radar tracking resources are spread thinner, communication channels become busier, and command decisions become more complex. In such conditions, delays and mistakes are more likely. Even a brief lapse in coverage can create an opening for real aircraft to pass through. Decoys can also be used to create false expectations. If air defense operators become accustomed to seeing certain flight profiles or routes associated with decoys, they may begin to assume that similar tracks are also decoys. This can be exploited by mixing real aircraft with decoy patterns, increasing the chance that a genuine threat is detected too late or not treated with sufficient urgency. This technique relies heavily on timing and intelligence, and it requires careful coordination. Israeli defense planners place significant emphasis on understanding how specific air defense systems behave under stress. Some systems prioritize automation, while others rely more heavily on human judgment. Some are centralized with decisions flowing from a central command node, while others allow local units more autonomy. Decoy tactics are adapted accordingly. The goal is not simply to overwhelm the system but to exploit its particular design features. The role of industry is also important here. Israeli defense companies including Rafael Advanced Defense Systems have developed decoy platforms that can be configured in different ways. Some decoys are designed to fly fast and high, mimicking strike aircraft. Others fly lower and slower, resembling surveillance or support platforms. This variety increases the burden on air defense operators, who must consider a wider range of possibilities from a strategic perspective. This method reflects Israel's preference for control and predictability. Instead of relying on a single decisive strike, decoy saturation allows Israel to probe defenses incrementally. Each operation provides feedback on how the defender reacts. Over time, this builds a detailed understanding of the system's strengths and weaknesses. This knowledge can then be used to plan future operations with greater confidence. There is also a psychological dimension. Air defense crews operating under constant uncertainty may experience fatigue and stress. Repeated alerts, missile launches, and high-tempo operations can wear down personnel. While professional militaries train for such conditions, sustained pressure still has an effect. Decoy operations, when conducted over time, can contribute to this strain without crossing the threshold of open conflict. It is important to note that this approach does not guarantee success. Well-trained defenders can adapt, refine their procedures, and learn to recognize decoy patterns. Modern air defense systems increasingly incorporate data fusion and artificial intelligence to assist operators. This makes saturation tactics more challenging and requires continuous innovation on the part of the attacker. Israel's approach reflects an awareness of this evolving contest. Legally and politically, saturation through decoys occupies a gray area. While decoys themselves are non-lethal, their use may be interpreted as preparation for attack. This can raise tensions, particularly in regions where airspace violations are highly sensitive. Israeli decision-makers must therefore weigh the intelligence value of such operations against the risk of escalation. This calculation is a recurring feature of Israel's security policy. In recent years, global conflicts have demonstrated how quickly air defense systems can become overwhelmed when faced with large numbers of targets, including drones and decoys. These examples reinforce the relevance of Israel's long-standing focus on saturation and distraction. They also highlight the importance of integrating decoys with other capabilities such as cyber operations and electronic warfare to maximize their effect. Ultimately, the use of decoy aircraft to overload and distract air defenses shows that modern warfare is as much about managing perception as it is about physical destruction. By shaping what defenders see and how they respond, Israel seeks windows of opportunity that reduce risk to its own forces. This approach requires patience, discipline, and a deep understanding of the adversary. It also underscores a broader lesson about contemporary conflict. The most effective operations are often those that remain unseen, measured not by dramatic explosions but by the absence of losses and the quiet accumulation of advantage. Decoy aircraft are a tool suited to this kind of warfare, where information and restraint play a central role. Air defense systems are not defeated by a single action. They are gradually weakened by pressure applied from different directions at different times and across different domains. Another key part of how Israel uses decoy aircraft is the way these platforms are integrated into a wider operation that includes electronic warfare, intelligence collection, and carefully timed follow-on actions. This integration is central to turning deception into real operational access. To understand this, it helps to look at air defense not as a wall but as a living system. Radars, missile batteries, command centers, and communication links all work together. If one element is disrupted or overloaded, the effectiveness of the whole network can drop sharply. Israel's approach is to use decoys as the trigger that exposes and stresses this system, while other tools exploit the resulting vulnerabilities. Israeli air operations are coordinated by the Israeli Air Force, which places heavy emphasis on synchronization. Decoy aircraft are rarely launched alone. They are introduced into airspace at moments chosen to coincide with electronic warfare activity. As decoys approach defended zones and force radars to activate, electronic warfare systems begin to interfere with those same radars and communications. This combination serves several purposes at once. First, it makes it harder for air defense operators to clearly interpret what they are seeing. Radar returns may be distorted, intermittent, or delayed. Communication between units may suffer from interference. Under these conditions, even experienced crews may struggle to maintain a coherent picture of the airspace. Second, electronic interference during decoy operations provides valuable feedback. Israeli sensors monitor how air defense systems respond when their signals are degraded. Do they switch frequencies? Do they rely more heavily on backup radars? Do they fall back on optical tracking? Each response reveals something about the system's design and training. This information is often more valuable than the immediate tactical effect. Another critical aspect is timing. Decoys can be used to create predictable patterns in air defense behavior. For example, if defenders tend to activate certain radars or reposition missile batteries when they detect incoming targets, decoys can be used to trigger those actions deliberately. Once those patterns are understood, Israeli planners can schedule real aircraft movements or strikes to avoid the strongest defenses or exploit temporary gaps. Decoys also play a role in protecting manned aircraft during operations that require physical penetration of defended airspace. By drawing attention and resources away from the main axis of attack, decoys reduce the density of defenses facing real aircraft. This does not eliminate risk, but it helps manage it. In a region where losing an aircraft can have strategic and political consequences, even small reductions in risk matter. Israeli defense companies have supported this integrated approach by developing systems that are designed to work together. Companies such as Rafael Advanced Defense Systems have focused on compatibility and reliability. Decoys must be able to operate in environments saturated with electronic signals without being disrupted themselves. At the same time, they must be predictable enough to fit into detailed operational plans. From a geopolitical perspective, this method reflects Israel's broader strategic posture. The country often seeks to achieve objectives quickly and decisively, while limiting the duration and visibility of military actions. Integrated decoy operations support this goal by increasing the chances of success in the early stages of an operation. If air defenses can be penetrated or neutralized early, the need for prolonged campaigns is reduced. There is also an escalation management dimension. Electronic warfare and decoys can operate below the threshold of open conflict, especially if no physical damage occurs. This allows Israel to gather intelligence and prepare contingencies without immediately triggering retaliation. However, this balance is delicate. Air defense operators may interpret sustained interference as hostile intent, increasing the risk of miscalculation. The integration of decoys with intelligence collection is another crucial element. Signals gathered during decoy operations are analyzed in detail after the mission. This analysis feeds into databases that track radar characteristics, communication protocols, and response times. Over months or years, this builds a highly detailed picture of an adversary's air defense posture. Future operations benefit from this accumulated knowledge. It is important to note that this approach demands discipline and restraint. Poorly coordinated decoy and electronic warfare operations can interfere with friendly systems or reveal capabilities prematurely. Israel's emphasis on training and planning is therefore essential. Crews must understand not only their own role, but how it fits into the broader operation. The effectiveness of integration also depends on adaptability. Air defense systems evolve, and so must countermeasures. Israeli planners assume that any tactic once used will eventually be studied and countered. This is why decoy operations are rarely repeated in the same way. Variation in timing, routes and combinations of tools is key to maintaining effectiveness. Recent conflicts elsewhere have highlighted the importance of this integrated approach. Attacks that rely solely on numbers or speed often fail against layered defenses. Those that combine deception, interference and precise timing have a better chance of success. Israel's long experience reinforces this lesson and explains why decoys remain a relevant tool despite advances in sensor technology. At a deeper level, the integration of decoys with electronic warfare and intelligence reflects a philosophy of control. Rather than reacting to an adversary's defenses, Israel seeks to shape how those defenses behave. This does not guarantee dominance, but it increases predictability in an unpredictable environment. This approach also has implications for future conflict. As air defenses become more networked and automated, the battle may shift further toward information warfare. Decoys may evolve to interact dynamically with defenses, adapting in real time. At the same time, defenders will seek to harden systems against deception. The competition will continue, driven by the same basic logic. In the end, Israel's use of decoy aircraft is best understood as part of a layered method, not a standalone trick. Decoys expose, electronic warfare confuses, intelligence analyzes and follow-on actions exploit. Each element reinforces the others. This coordination reduces risk, improves effectiveness and aligns with Israel's need for precise, controlled military options. Beyond tactics and technology, another essential part of how Israel uses decoy aircraft lies in how lessons are absorbed, refined, and carried forward over time. Decoys are not only tools for a single mission, they are instruments in a long process of learning. This continuous cycle of testing, feedback and adaptation is a key reason why decoy-based approaches remain relevant despite changes in air defense technology. Israel operates in a strategic environment where repetition is unavoidable. The same air defense systems may be encountered multiple times over years or even decades, sometimes upgraded, sometimes operated by different crews, but often built on familiar foundations. This continuity allows Israeli planners to think in terms of long-term understanding rather than one-off success. Decoy aircraft are central to this approach because they can be used repeatedly with relatively low political and military risk. Air operations are overseen by the Israeli Air Force, which places strong emphasis on post-mission analysis. Every decoy operation generates data. Radar emissions, communication signals, missile launches, response times and operator behavior are all recorded. After the mission, this information is examined in detail. Analysts look for patterns, anomalies and changes compared to previous encounters. This analytical process serves several purposes. First, it helps confirm or update existing intelligence. Assumptions about how an air defense system works are tested against real-world behavior. If a system reacts differently than expected, that discrepancy becomes a focus for further investigation. Over time, this reduces uncertainty and sharpens planning. Second, the feedback loop informs training and doctrine. Lessons learned from decoy operations are incorporated into simulations and exercises. Pilots, electronic warfare crews, and intelligence officers are trained using scenarios based on real data rather than theoretical models. This grounds preparation in reality. Thank you and reduces the gap between training and combat conditions. Decoys also allow Israel to observe how adversaries learn. Air defense operators adjust their tactics, change procedures, and update software. By comparing responses across multiple encounters, Israeli analysts can assess the pace and direction of these adaptations. This insight is valuable because it helps predict how defenses might behave in a future crisis, not just how they behave today. Israeli defense companies contribute to this learning process. Firms such as Rafael Advanced Defense Systems work closely with the military to refine decoy designs based on operational feedback. If a decoy fails to trigger the desired response, engineers look for reasons. Was the radar signature insufficient? Was the flight profile unrealistic? These questions lead to incremental improvements rather than radical redesigns. This steady refinement reflects a broader Israeli approach to military innovation. Instead of waiting for disruptive breakthroughs, emphasis is placed on reliability and usability. A decoy that performs consistently and predictably is more valuable than one that promises advanced features but fails under real conditions. This mindset aligns with the realities of operating in contested airspace on a regular basis. From a strategic perspective, this learning-focused use of decoys supports deterrence. Adversaries know that their air defenses are being studied over time. Even if a decoy operation causes no immediate damage, it signals persistent attention. This can influence how defenses are deployed and how confidently they are relied upon. Uncertainty about whether a system's weaknesses are known can be as unsettling as the knowledge that they are. There is also a political dimension. Decoy operations, especially when they do not result in destruction or casualties, often remain below the threshold of public escalation. This allows intelligence collection and preparation to continue without forcing overt confrontation. However, this subtlety requires restraint. Excessive or careless use of decoys could still provoke incidents or misinterpretation, particularly in tense regions. Another important element is institutional memory. Israel's security establishment places value on preserving knowledge across generations of personnel. Data gathered from decoy operations years earlier may still be relevant when new crews take over. This continuity helps prevent the loss of hard-earned understanding and ensures that lessons are not relearned at unnecessary cost. The limits of this approach are also recognized. Learning is only useful if assumptions are periodically challenged. Israeli planners therefore avoid becoming overly confident in any single method. Decoys are tested against new systems and new conditions, and failures are treated as opportunities for insight rather than simply setbacks. This culture of critical evaluation is central to maintaining effectiveness. In the broader context of modern warfare, this emphasis on learning highlights a shift away from decisive single battles toward ongoing competition. Air defenses and countermeasures evolve together. Neither side achieves permanent advantage. In such an environment, the ability to learn faster and adapt more effectively becomes a key measure of strength. Israel's use of decoy aircraft illustrates this dynamic clearly. The value of decoys lies not only in what they accomplish in a single mission, but in what they reveal over time. Each operation adds another layer of understanding, another data point in a long-running analysis of adversary capabilities. This approach also underscores a human reality. Technology may change, but decision-making under pressure remains a constant. By studying how systems and operators respond to stress, Israel seeks to reduce uncertainty in future crises. Decoys provide a way to conduct this study without resorting to open conflict. In the end, key point 5 is about persistence and learning. Decoy aircraft are tools for observation as much as for deception. Their real strength lies in how they feed a disciplined process of analysis and adaptation. This process helps explain why Israel continues to invest in decoys, even as air defense technology advances. In understanding how Israel uses decoy aircraft to penetrate air defense systems lies in recognizing both the limits of this approach and what it suggests about the future of air warfare. Decoys are effective, but they are not magic solutions. Their value depends on context, restraint, and a clear understanding of how conflict dynamics are changing. Israel's continued use of decoys reflects an awareness of these limits as much as confidence in their usefulness. At the operational level, decoy aircraft work best in environments where intelligence preparation is already strong. Israel does not launch decoys into unknown airspace hoping for random results. Operations are based on prior intelligence, historical data, and assumptions that are then tested and refined. Without this foundation, decoys risk becoming expensive signals with limited analytical value. This reinforces the idea that decoys are multipliers of intelligence, not substitutes for it. Air operations are managed by the Israeli Air Force, which has consistently shown caution about overusing any single method. Israeli planners assume that adversaries are watching, learning, and adapting. A tactic that works today may be less effective tomorrow. As a result, decoy use is carefully paced. Some opportunities are deliberately not exploited, preserving uncertainty for future scenarios. One major limitation of decoys is predictability. If decoys follow similar routes, altitudes, or timing patterns, air defense operators may eventually identify them with greater confidence. Israel mitigates this risk through variation, but variation itself has limits. At some point the range of believable flight profiles narrows. This reality forces planners to think creatively while remaining grounded in realism. Another constraint is cost. While decoys are cheaper than manned aircraft, advanced decoys with multi-signature capabilities are not inexpensive. They require maintenance, secure communication links, and integration with other systems. Israel must therefore decide when the intelligence value of a decoy operation justifies its expense. This calculation is influenced by the strategic importance of the airspace in question and the likelihood of future conflict. There is also a political ceiling. Even non-lethal decoy operations can be interpreted as hostile acts. In highly sensitive regions, repeated airspace incursions may provoke diplomatic fallout or unintended escalation. Israel's leadership must balance military preparation with political signaling. This balance is not static. It shifts with regional tensions, leadership changes, and international pressure. Looking ahead, the future of decoy aircraft is closely tied to the evolution of air defense systems. Defenders are investing in sensor fusion, automation, and artificial intelligence to reduce reliance on human judgment under pressure. These systems aim to classify targets more accurately and resist deception. Israel's experience suggests that this will not eliminate the usefulness of decoys, but it will change how they are designed and used. Future decoys may focus less on simple imitation and more on interaction. Instead of merely triggering responses, they may be designed to elicit specific defensive behaviors, testing how aided systems prioritize threats or allocate resources. This shifts the role of decoys from passive bait to active probes. Such developments, however, also raise new risks, particularly if automated systems respond in unpredictable ways. Another trend is the convergence of decoys with other unmanned systems. The line between a decoy, a reconnaissance drone, and a strike platform is becoming less clear. Israel's approach so far has been to maintain conceptual clarity, ensuring that decoys remain tools for observation and deception rather than ambiguous weapons. This clarity helps manage escalation and maintain legal and political control. From a broader geopolitical perspective, Israel's use of decoy aircraft highlights a wider shift in military competition. Power is increasingly measured by how well a state understands and shapes its adversary's systems rather than by how much force it can deploy. Decoys fit this logic because they are designed to extract insight rather than produce immediate destruction. This approach also reflects a sober understanding of risk. Israel operates under constant security pressure, but it also recognizes the costs of miscalculation. Decoys provide a way to reduce uncertainty before committing to higher-risk actions. In that sense, they support stability as much as they support military effectiveness. There is a human element here as well. By relying on unmanned decoys, Israel reduces exposure of pilots and aircrews. This is not only a moral consideration but a strategic one. Losses can have cascading effects on public opinion, morale, and decision-making. Decoys offer a way to gather information while keeping people out of immediate danger. At the same time, Israel's experience suggests that no system, decoy or defense, ever provides permanent security. The interaction between attackers and defenders is ongoing. Each side learns from the other. The advantage lies with those who learn faster and apply lessons more carefully. Decoys are valuable because they accelerate this learning process. Then is about realism and restraint. Israel uses decoy aircraft not because they guarantee success, but because they offer a measured way to understand and manage risk in a complex environment. Their effectiveness comes from how thoughtfully they are employed, how carefully their results are analyzed, and how cautiously conclusions are drawn. In modern warfare, quiet preparation often matters more than visible action. Decoy aircraft are part of that quiet work. They rarely make headlines, and when they do, details are scarce. Yet their influence can shape outcomes long before conflict becomes visible to the outside world. Understanding this helps move the discussion beyond myths of technological dominance or clever tricks. It shows a system built on patience, analysis, and adaptation. In that sense, Israel's use of decoy aircraft is less about deception alone and more about disciplined control in an uncertain strategic landscape. If you found this analysis useful, don't forget to like, share, and subscribe for more war updates and global analysis.